For this, I will introduce you about the orbit more take. So if you are some developers, so you maybe need this. Okay, so who I am? I'm Jason, and I based in China now. I am integration engineer at Off-Chain Labs. Off-Chain Labs is the team to build the Arbitrum. So we build Arbitrum One, we build Arbitrum Nova, and we also have some. We also build some take like Arbitrum Natural and Arbitrum Stylus. Also, the Arbitrum Orbit is what I will introduce now. If you have any technical question about Arbitrum or about Web3 technology, you can just add my Telegram. My Telegram is there, so feel free to add me and drop any question. Okay, so what is Arbitrum Orbit? We all know Arbitrum 1 and Arbitrum Nova has a lot of users on it, but with the time flows, so there might be more needs to use Arbitrum. So just Arbitrum 1 and Arbitrum Nova may not enough. So we introduced the Arbitrum Orbit to allow people or allow other teams to build their own chain, their own application chain to sit on Arbitrum 1, Arbitrum Nova, or any other layer 1, layer 2. So with the Orbit, you can build your own application chain like the game chain. If you want to build your own game, you just if you just build on Arbitrum One, it might be so crowded. So if other dApps or other games on Arbitrum One has a lot of users, it may increase the gas price on Arbitrum One or Arbitrum Nova. So if you build your own Arbitrum Orbit, you don't need to worry about that. You own your chain, and the users on your chain is just for your own game. So it will be easier for you to have your own chain. So with the Orbit, you can also build your own smart contract, like I said. So what is smart contract? I will introduce you. Is smart contract is simply a program which is built on the blockchain. If you want to build some apps, some dApps, or some game or other applications, you can just deploy your own smart contract. You don't need to worry about the contract. Contract doesn't mean the real contract. It's just a code, a program run on blockchain. So why we call it as a contract is because the logic is predefined. So nobody owns the smart contract, but just the users or the blockchain owns the smart contract. It doesn't like the application offered by some centralized big company like Google or like other company. The blockchain smart contract is owned by the blockchain itself, so it won't be contract. It won't be controlled by any other part. So you don't need to worry your data will be logged by others. So this is a smart contract. So okay, let's back to the Arbitrum Orbit section. At the start, the Arbitrum Orbit just allow you to deploy your own chain on Arbitrum 1 or Arbitrum Nova. Also, the testnet called Arbitrum Supporter. But we know it's kind of not user friendly because someone also want to build their orbit on layer 1 like Ethereum or other layer 2 like Base or other ZK swaps. So at that time, if you want to deploy your layer 2, you need to get the permission from our DAO. But now we introduce our Arbitrum expansion program, which allow you to deploy your orbit permissionless on any other Ethereum-based chain like Ethereum itself or Base or Optimism or other ZK swaps. Okay, so this is how Orbit chain looks like. You can now build on layer 2 or layer 3. The there is not so much difference between those two. It's the only difference between you build a layer 2 or layer 3 is just the base layer is different. So if you want to build on layer 3, you will have a cheap layer 2 base, so you can send your transaction to layer 2 frequently. But if you build a layer 2, you can just directly get on the Ethereum, so your users can onboard your chain from Ethereum directly. They all have their pros and cons, so it depends on your need. Also, not only the technology, you can also build your chains by rollups or any trust. I think this is already introduced by Taika, and I will introduce you more about rollup and any trust later. So for now, as I introduced before, the orbit chain just like this. You can have your orbits like those two type. You can enjoy it or whatever you want. So okay, what is the orbit and what does the orbit do when they deployed? So if you want to deploy your orbit, it's just like a layer 2 chain or layer 3 chain, but you need to deploy the smart contract on the base chain to secure your orbit chain. Like if you want to transfer your funds to your orbit, you need the smart contract on the base chain, and also you will have the fraud-proof system on the base chain. The fraud-proof system also needs a smart contract like inbox contract, like rollups contracts or other fraud-proof contract. So those contracts you need to deploy on the base chain. And how you can customize your chain is you can customize anything. You don't need to follow any rules, but just customize is whatever you want. For example, if you want to have your chain, the gas token is your own token, not the ethers or other tokens. You can have a customized gas token. Also, we all know there are many EIPs to expand the Ethereum blockchain, but some EIPs may not go online due to some reasons. So with the Orbit, you can just deploy any EIPs like the EIP 1153 and also others EIPs. Besides that, you can also have your native account abstraction on your Orbit chain. So what is this? This is a technology which can let your users to send the transaction but without any gas fee. We know some people afraid to use the blockchain is because every transaction you send to blockchain needs a gas fee. So it will be some it will be kind difficult to use because you need to charge your money or use your money to send the transaction. But with this, you can let your users to send the transaction without any funds, without any gas fee. So this is good for others who want to onboard more users on blockchain. And for the third part is access console. The access console is to use to if you want to build an AI chain or some other chain, but you don't want to open it to all users, you can have the access console. So only the users in whitelist can use your chain, and also any other else you think of. Also, I will introduce you about the pre-compare contract to customize later. And for the gas price reliability is what I introduced before. So if like what I said, if you use Arbitrum 1 or Ethereum, you will find there are many other dApps on the blockchain. So if other dApps have more users to send the transaction, it may increase the gas price on Arbitrum 1 or on Ethereum. So it will be kind of annoying to let your user to have a high gas price. So for this, you can deploy your own Orbit chain. It will have your own block space, so you don't need to worry about other dApps will affect your gas price. In case of this, so you can have more people, more users to use your chain, and also other customizations logic. For example, if you have a large community, you can build your own governance systems, or you can net your governance system to have your own vote logic. And for also, if you are familiar with the layer 2 or the modular blockchain, you will know it's also necessary to have other data availabilities layers, just like Celestia. So you can also choose your DA layers, the like Celestia, like layers, like all other layers. Also, the most interesting thing is you can to customize your own challenge protocol, because the challenge protocol is a protocol to to secure your chain. Like the fraud proof Taka already introduced to you at the start. The challenge protocol like fraud proof, or you can also use the ZK proof to your Orbit chain. This is all possible to your chains. Okay, so what is the opportunity to do? You can also find here. So for layer 2 or layer 3, if you directly use the layer 2, you will know some transaction might lead to send to layer 1, and the layer 1 has a super high gas price. Also, it needs 12 seconds to include your transaction. So with layer 3, you can send your transaction to layer 1 more frequently, because the layer 2 is cheap enough, and you don't need to worry about the block time, because the block time on layer 2 is just it's super fast, and sometimes even lower than 1 second. Also, with Orbit, you can enjoy all the future updates from the off-chain apps. Just like the Stylus. The Stylus is a tech to which allowed you to deploy the contract not only the Solidity, but also some Rust, C++, C uh, C language. So if you are familiar with those three languages, you can now use Stylus to deploy your contract, which we will introduce you this afternoon. With the Stylus, if you are familiar with Rust or C++, you will know those two languages can be used to onboard some AI programs. So with the Stylus, you can even onboard your AI to the blockchain, which is super interesting to see. And of course, the benefit of Orbit is you can also bridge your token to your Orbit more cheaper. For example, if you bridge a token from layer 1 to layer 2, you may need more than $10 to send that. But if you want to bridge the token from layer 2 to layer 3, it only costs one one cent or even more cheaper. So if you want to use users to spend less money on this, you can definitely deploy your own Orbit layer 3. Okay, so how can you launch your own Orbit chain? Here we go. I will introduce you how to launch it. So if you want to launch your Orbit chain, you can visit this website. This website will guide you to launch your Orbit chain super easily. So let's go to this website. So if you go to this website and click the deploy new Orbit chain, you will find the UI. Here, we have two choices for you to deploy. One choice is rollups, and another choice is AnyTrust. So, what is the difference between rollups and AnyTrust? Their main difference is here. The about the DA to send to the blockchain. The DA is the blockchain data which you need to be backed up. So if you can restore your chain anytime from read the layer 2. If you read your layer 2, you can restore your layer 3 directly. So this is rollups. Rollups will send all the blockchain data, we call the DA, the data availability data, to layer 2 chain. But for AnyTrust, it just send the DA to the data availability commit. So it will be much cheaper because the DSA won't cost too much to store your data, and it will, after it store your data, it will generate a signature back to the sequencer, and the sequencer will send the signature to layer 2 chain directly. So for the AnyTrust, the layer 2 chain that just need to store the signature, but for rollups, it need to store all the DA data. So as for this, AnyTrust will be much more cheaper than the rollups, but rollups has all data backed up, so rollups will be more permissionless and more security than the AnyTrust. So for the user case, AnyTrust can be used to do some game or do some other depths needs a lot of gas. And for the rollups, you can build your own decentralized finance apps on the blockchain, like the decentralized exchange or other decentralized applications, which may need more security. So after you choose the chain type, you will, for example, if we choose the rollups type, okay, then you will say those field, and those field has a lot of information like chain ID. The chain ID is the ID to specific your chain. So others, so when users send a transaction to your chain, users will have this chain ID to specific the transaction is sent to your chain. So there won't be the double spending issues here. And the chain name, you can just change it to any other chain name you like. Maybe the frog chain or other chain or rabbit chain or any other chain you like. Then it's about the challenge period. The challenge period is for the fault proof and also for your chain security, and others is the stake tokens. The stake token is when there is a new validators to join your network. The validators need to stake the token to secure your chain. So for here we use ETH as an example, and others you can also change it. For example, the owner of your chain to you can also set the owner to the DAO address. So if your chain need to upgrade, it will need the DAO's approve. And okay, so this is all the need. After you click the next, you will get this UI, and it will ask you to send the transaction to deploy your chain. After you deploy your chain, you will say this UI, and this UI will have some information about your chain. Those two information is to help you deploy the chain and run the chain. So you can also, if you want to run your chain your own, you need to download it, and it will get you those two files. Okay, so after you get those two files, you need to visit the Orbit setup script repo and download this repo. Use the Git pull. Then you download scripts, and you need to install some toolkits from it. So yum install, and later the second part is to run your chain. If you run the Docker Compose app, it will run your chain directly. So your chain is now running. And but this is just to start your chain, and your chain doesn't have others contract deployed. For example, the bridge contract. If you want to onboard your users, you definitely need to deploy some bridge contract. So after that, you need to run this line. This line will help you to deploy your other contract which is needed to onboard your users. Then if all set, you can just run this command to see the logs. And this is a link to this script. I will send this slides in the Telegram group later. Okay, so now it's all done. Now you can have your chain running on this URL. If you want to visit your chain or send any transaction to your chain, you just send it to this URL. This URL will accept any RPC request. So you can send any ETH RPC request to this link like to query your block numbers or query the histories block. And you will also have the block score running on this URL. It will run on the 80 port, so you don't need to add the port at the end. Okay, so this is all we need. After you run the script, after you run this script, it will also generate a file named output inform.json. This file will contain the chain config and some cool contract address, also the token bridge contract address. So you can just use this output info to then copy that to our bridge website and insert this output info.json to that website. Then that website can recognize your chain and to let your users to send the assets or their other tokens to your chain. Okay, that example is for rollups. So what if we want to deploy the AnyTrust blockchain? So the main difference is here, the gas token. If you want to deploy your chain with the customized gas token, you need to deploy the AnyTrust chain. The AnyTrust chain allow you to use your own tokens to be the gas tokens. For example, if you launch your own token named Force, so you can just choose the customize and then input your tokens address into here. It is headed. So after that, you can click the deploy. Then it will deploy your chain. So for the custom gas token, you need to care about is the custom gas token just allow you to be the standard ERC20 tokens. If you have your ERC20 token with 18 decimals, so you can use it. But if you want to use some token with other decimals, maybe it's not work because the code because of the code base. Like if you want to use USDC, it may not work because USDC doesn't use 18 decimals. So others is just to tell you, you need to use the standard ERC20 tokens. Okay, after you deploy it, you will see your K set. The K set is the key to specific what is your DSA and what number of your DSA members. So it will record it on your base chain. So when your AnyTrust send the AnyTrust say signature or the data to L1 or the data to the base chain, it will check the key set and to check if the signature is right or not. Besides that, we also have the Orbit SDK. You may say the UI just let you to deploy the standard orbit. So if you want to deploy some advanced orbits, you can use our SDK. The SDK has a lot of examples. Those are the examples. You can deploy the customer fee token rollups or also the ETH rollups and also other node config. You can call your orbit, use the SDK to upgrade the node config also. So it will be quite easy to use that if you don't want to use the UI to deploy your chain. Okay, those are the resources and the tools you may need if you want to deploy your Orbit chain. Those introduction are just for the simple users. So if you want to have more details on the Orbit, you can visit our docs. These docs will guide you to deploy your chain and customize your chain. And also we have the tools to monitor to your Orbit chains. You can also go to this GitHub repo and download the tool. Okay, that is for the Orbit chain. If you want to do more advanced test on your Orbit chain, or you want to customize your chain more advanced, I will introduce you about this. So before this, I need to introduce you about the state transition function. We call it as STF. So the STF defines how the blocks are produced from the input message. Like if you have the user's transaction to your blockchain, then the blockchain will use the STF to get your transaction and then output the state and also the L2 blocks. Here is what our STF likes. So if this is the load, then those two parts is the STF. The first part is just for users to use, like the RPC method or some other tools. User can use this to query the chain. So after this is the STF system. The STF system will help you to execute your transaction. Next, the OS will manage the system running, and the guest query will execute your transaction. So if you want to do some customize to your chains, you might will affect the STF, but you also won't affect the STF. So in what way you do to your blockchain will infect the STF is if you want to add a new RPC method to query the chain, it won't, because the RPC method is in this part, and if you just query the chain, it won't need to do any execution on chain, so it won't affect the STF. So you are free to just edit it. And also, if you want to add some change to your sequencer, like you want to have some tips when your sequencer accepts the transaction and order the blocks, you can also change it, because it will either won't affect the transaction execution, because the transaction will first be ordered by the sequencer and then input to the STF to execute. So those two examples won't affect your STF, but for those two other examples, like if you want to add some OP code, the OP code is kind of low-level code which is used to be read by your machine. And also, if you want to add a new pre-compare, the pre-compare will also lead to you to modify the STF. Because the pre-compare will be called by other contractor or other users, and this pre-compare will talk to the OS directly. So besides that, if you want to change your smart contract, like the smart contract, like let the smart contract won't charge any gas from your users, you can also need to change the bar, change that, but it will affect the STF also, because imagine if you add this, and after that some other load to sync the load, you charge the users only a few gas, but after that other load want to sync the transaction, but it doesn't change the STF, it will charge the users as usual, so it will be different after execute the transaction. The user's funds will be deducted wrong. So as we introduced here is a pre-compare. So what is the pre-compare? The pre-compare is another type of smart contract. Like we just introduced the what is a smart contract as a start. So for this, the pre-compare is predefined contract which is which is not deployed by the users or other contract, but it was deployed during the chain genesis or during the chain upgrade. So this pre-compared is deployed on the protocol level rather than the application level. The pre-compare contract can be any contract, like if you can use a pre-compare to calculate the hash, or you can use the pre-compare to do some advanced computations. So this is what pre-compare does. In sum, is the pre-compare is deployed on the protocol level, so it will not be deployed by the users. So here is the example if you, how to edit the existing pre-compare if you want to customize your orbit chain. For this, you need to open the, if you want to just to edit but not add, so you just need to open the existing pre-compare file, and then when you go to this file, you can add your new method or edit the existing method. The method is to define how your pre-compare executes, and the pre-compare is written by the Go language. Then you need to upgrade the contract API. The contract API is the interface of the contract. If your users want to call your contract, it will use this contract API to call your contract. Because if you are a coder, you will know if you want to call other method, you need to know the interface of that method. So this is how smart contract works here. Then after you change your logic and update the contract API, you can compare the natural source code. The compare is super simple because we already have the tool for you to compare it, and then after you compare the natural source code, you will get the new Watson module root. The Watson module root is a root for your STF. For example, if you change your STF, you need to let your base chain to know the correct of your natural code. So this is what is recorded on the base chain to verify. When you get the new Watson module root, you need to register this new Watson module root to your base chain's ROPS contract. Then you can finally run your load. So what if you told me you don't want to edit the existing one, but you want to create your new pre-compare? Okay, we can do this too. The main difference is you don't need to open the existing one, but you just need to create a new pre-compare file, and then you need to create a new contracts ABI file too. Then you need to choose a pre-compare managing files, managing code to register the pre-compare. Then the other part is almost the same to the first one. Okay, we have a sentence which is talk is nice. Show me your code. Okay, so now we can show you the how to edit it through the code. Here we will use add the new pre-compare contract as the example. So we will use this page as an example. So here is our Ledger code base, and you need to find a directory named pre-compares, and then you need to add a new file here. The new file, because it's just an example, so we just call it as RB high. So because it's RB high, so it's a very simple contract. It will just return a high string when you call it. So this is a logic we define. And then you need to register your contract ABI. So you need to go to the contract directory and find the SRC, then find the pre-compares and create your new ABI here. Because we called it RB high before, so we also named it RB high here. You need to make this file as Solidity contract because it's a Solidity ABI. So here is what the ABI looks like. Also, it's just a contract interface, so you don't need to create APIs. It will create the API for you, but you just need to write down your interface, your smart contract interface. So after this, you need to register your pre-compare contract, and you need to go to this file. This file is used to manage your pre-compare, all your pre-compare contracts. So here, when you go to this file, you need to find a method called pre-compares, and this function will help you to register your pre-compare. Then you can find this line. This line is a new line to register your pre-compare. Is the method just called insert. Then you can call this insert and call make pre-compare for it. Here is the address of the contract, because we all know the pre-compare contract is almost the same to the user deployed contract. So as the user deployed contract have the contract address, so the pre-compare contract also have the address. So we just give it a super simple address which is 11A. Okay, after this, you need to compare your chain. So the compare is super simple. You just need to go to our Nitro code base and type make Docker. Then it will help you to compare the source code. But it may take some time, maybe maybe 20 minutes to compare it. So after this, the load will be compared and will be made to a Docker image. Then you can run the Docker image to the Watson module root. Just use this line. After that, you will get your new Watson module root. So how to register new Watson module root to our smart contract is super simple. You need to find the file which we generate after you deploy your Orbit chain. One of the file has those information, like the rollups contract address and the upgrade executor address. So for this you only need two address of those two. Then you can go to call this method through your rollups contract. So if you want to call your rollups contract, you need to go to the contract and you need to use your upgrade executor and call it from the upgrade executor. Then if you go to the upgrade executor and you will find a method called execute call. So this is the function we need to call. Then you need to input your target here. The target is your rollups contract address, and the target call data is start with this number. This number is the signature of the method name set Watson module root. So you need to start with those code and then followed by your Watson module root. Then you put it together and you just call this method. Then okay, so after that, your Watson module will be upgraded, and you can test it from your rollups contract directly. You can call your rollups contract this method named Watson module root, and then you will get the Watson module root like this. So okay, so our pre-compare contract is all done. So after this, if you want to call your pre-compare, you can just use the cast call. The cast call is a Foundry toolkit, so you just call it. The address is what we said before, and the say hi is the method we defined before. Okay, so let's call it, and then it will result the hi, just as we defined before, just as we defined here. So it will successfully return you the value. Okay, so this is how to change the STF code. If you want to do more things about the STF, you can visit our docs and also you can this link is wrong, but you can also find the customized pre-compare link around this link. Okay, so this is how Arbitrum orbit works, and if you want to change your orbit, customize your orbit, you also it's also here. Here is an example to change your orbit. So thank you. If you have any question, please feel free to ask here, or also you can at my Telegram, so we can chat there too. Thank you.